So welcome everyone to this month's webinar. And this month's webinar is on our compact PLC offering known as the Nexto series. And I'm Alan Williams with Bear Electronics. So for this webinar, all lines are muted, but we will be taking questions via the chat box that you can see. Typically it's at the bottom right of your screen. And if you want to locate that now. So what will happen is I will be moderating the questions. So if you type in a question into the chat box, what I'll do is in real time, I'll ask the presenter that question, and then we'll get you responses straight away. So let me introduce today's speakers. We have Gabe Barrett. Gabe is our senior applications engineer here in the US. Now joining Gabe will be Leandro Profes, who's with our partner company Altus, and he's a product director for North America for their product offerings, which includes the PLC offerings as well. And between them, they have decades of experience in automation and controls. So as mentioned, if you do have any questions, please type them into the question box and we will answer them as we go. So to begin, Gabe would lead things off. Over to you, Gabe.
Thanks, Alan. All right, so first I'm going to recap of, if you happen to catch last month's webinar, we did it out fully on BCS tools with a demo from our team in Sweden. Now, today I'm just going to recap a couple minutes of it before we get onto the use cases of how our Nexto product has actually solved solutions and how it's being applied out in the field today. But first, what I'm going to show you is, I'm going to show you where you can actually get BCS tools. So coming to our bearelectronics.com website, we can come here to the Smart Store, and you have BCS tools right here, all ready for you to download. You do have to have an account created because we mark off that you've accepted the end user license agreement. So you do have an account, but it is free download. All right, there's multiple versions of BCS tools, and right now the 3.31 I believe is the most current. But 3.30 is the one that is kind of revolutionary for us at Bear. And the reason for that is because what we've used in the past has been Codesys. All right, BCS tools is a Codesys-based program. Now I'm going to show you here as soon as I open up the actual integrated development environment of how similar they are and how they work, is that I'm going to show you how they can be almost interchangeable. All right, so if we actually come here to BCS tools and we actually go, let me come up here to my software from our Smart Store up here in the nav bar. You can see we have all the different versions of our software. All right, there's a box there that we can tick and have it show us the last version, the latest version of what has been released. And now you can see here that we also have Codesys available. All right, so we can download those, put them in our cart and check out after we accept the end user license agreement. But when we get down to it and actually launch BCS tools, we get a startup screen that looks almost identical to Codesys. Now, Codesys is a 61131-3 standard for all your programming, PLC programming languages, and so is Codesys. So is BCS tools. All right, so when we actually launch a project, we come here, center project, you're going to see a whole bunch of different options. Now, what separates BCS tools and Codesys is that we have removed all the bloat that happens that's in Codesys that we can't use with our hardware because it's not our product. But now BCS tools, we removed that and we said, okay, here's a bunch of stuff that actually helps us for our software. Let's make things easier for our customers. So you can see here in this drop-down list, we have all of our different controls, a power fail and a cyclic version of each product. All right, that comes downloaded already with BCS tools, where in Codesys, although you can still use the same programming languages, you would have to go through and add these individually for what product you actually want to use. So it already includes some of your configurations to save you some time. Now, in the actual BCS tools with one launched, we can look at, with one launch, we actually have the XP340 loaded up in this particular project, and you can see that we have a file structure much like Codis's. All right, it's literally almost identical. But depending on what device you have, you'll get an image of that device where you can click and drag different things. Like say if you were to use our modular PLC, you'd be able to click and drag and add those to it. So you get the graphical representation of what your object, your controller will look like. All right, you still have all the same configuration points. You can set your I/O, you can set your Ethernet connections, your IP addresses, all those things done right inside here. Now, if you've ever used our Warp software, there's a lot of features in there that were extremely helpful. And so this 3.30 is basically the first version where we can pull in a lot of those features and put them into this one software, this one BCS tool, so you're able to get all what you need from this. So this could be a one-stop shop. You can simulate, debug, and run your PC as a PLC using BCS tools. All right, Leandro, let's go ahead and look at some use cases and how this is placed in the field.
Hi, hello everybody. So my name is Leandro. Thank you for introduction, Alan. Thank you for the presentation, Gabe. I just need you to hand over here, show my screen. Can you see my screen? Can someone just confirm that for me, please?
Yes, Leandro,
okay.
We can see your screen. Thank you.
Okay, great. So the idea today is to go over some cases of Nexto series. So we will have some of them for Nexto Express, the small guy, and some of them for the modular, that is the big guy. As you see, as we just saw, Gabe showed us this programming software. Please keep in mind that the programming software is the same for all the products, and once that you start with, for example, Nexto Express, you can convert your application and you can reuse your application to the medium size or large size PLC. Once that you learn to use the small one, you have learned to use the big one. So please keep that in mind. Questions, go to the chat and I will try to address all of them. So we're starting from, over here. So we're starting on Nexto Express, the compact PLC. We have one case here that is water and wastewater. So we get a great challenge from a countryside city with very old equipments and a limited budget. So this is a small city, about 15,000 people living there, and they had to upgrade the city water and wastewater service unit. They were running off budget, but they have to do that. So basically what they request us to maximize the utilization of all devices that they already have in the field. They want to optimize the maintenance and downtime, connect all the units to the control center. Actually, they didn't have a control center at that time. So that was something asked to us to build for them. And there was a huge problem because there was no physical connection to the units itself. So they are quite far away from the city. They have mobile network, but there is no physical internet or any cable to go there and to bring all the information to the control center. So one of the requirements was, okay, we have to use mobile network. There is no other reliable way to bring all the information. And of course, they want to monitor and control all the units and devices from the control center. So basically, they want to have all the information in just one center from all the units that they have in the field. So basically, what was our strategy going over here? Just let me get here. So we get 13 Nexto 325. So they have 13 sites where they want to control. Of course, we have an embedded PLC over here. So we are calling as edge controller with embedded PLC. And we were connecting through GPRS. So we could connect through 3G or 4G, but they don't need really fast information that time, and GPRS was more reliable for in the field where they were. We have some more stable signal on GPRS. Blue Plant was a SCADA system going to the control center, and we were using as a requirement from them Modbus TCP going from each unit to the control center and Modbus RTU to the field. So basically, some of the old devices that they have in the field, they were not connected. They didn't have Ethernet. Most of them has Modbus RTU, and some of them even doesn't have Modbus RTU, and we had to connect through analog inputs. So basically, Nexto Express oversees all drives for the pumps and collect all the data from the devices, sensors, valves, and all that fun stuff, and send the information to the data center. We have control in each unit, so each unit is controlling that field and sending over all the information to the control center. The system is responsible to centralize all control and supervision of the water and supply system. There is full autonomy, so even though we lose some connection to the SCADA system, we keep control in each unit. And of course, we can allow the operation here from the control center to act in each of the devices or the inverters or the pumps from the control center with access control. So we can control which operator can do what and who has access and privilege to start pumps or just to monitor pumps or something like that. We are monitoring here all levels of reservoirs, elevators, pressure of the reservoirs, supply network directly from the control center. So basically, we have full control from the control center, even though we don't have a direct connection to each unit running on a budget. So basically, the goal here was to add the PLC, the edge controller, using all the device, all the installation that they already had, and connect to a data center, to a control center, without bringing any wire or any big infrastructure to that. What was the result? So full control from all the things that they have to do from the water and wastewater, reduction of time and cost to the centralization of data in the control center. And the big one here was the optimization of resource for maintenance. So in the past, they didn't have the information, so they have to drive operator or technical guy to all the units, so 13 units, to start checking what was the problem. And when they have to do some tests, they have to drive 2 cars, one for one for the other, and start talking one to the other. Okay, bring up the pump, make some pressure, whatever. And now they have all the information in the control center, and they can go directly to where we have the problem. For this guy specifically, I'm proposing here some upgrades and some possibilities. That is something that we will do a little bit different if we can. They didn't because of the budget, but just to keep you in mind that with the same product, we can do something much, I would say, better for the automation itself. So instead of using GPRS, my suggestion was to use a USB 3G and 4G dongle. At that time, we are using a gateway. So we're connecting the Ethernet from the controller, and we have a gateway that is a new hardware to communicate through mobile. But now, from this year on, we have the feature in Express to connect a USB dongle directly to the controller. So I would say this is much better than the gateway that we have. Another thing, instead of using Modbus up to the data center, I recommend to use MQTT communication protocol. It's much faster, it's much more reliable. We save a lot of data over the network. We can go directly to a database. So we are using a lot of MQTT via 3G and 4G at the moment. Another thing, instead of using 325 Express, I would suggest to use 340. Why to use 340? Because 340 we have a web server embedded. So if the technical guy goes to the field and he wants to have all the information in a tablet, he can have directly from the field and try to do the maintenance from there without having to call the control center to get the information from the control center. Another option here is to add HMI, but for HMI, they didn't have a budget, and 340 is a few more bucks than 325. And to use CANopen instead of Modbus RTU to communicate with the drives. I'm a big fan of CANopen. It's much faster, much more reliable, much easier to configure than Modbus. Going further, again with water and wastewater, but now with Nexto modular. So we give you one overview of a small one. Now we go for the big one. So a big state in Brazil, central region, that is Minas Gerais, the name of the state, wants to improve water and wastewater service to improve its development's KPIs. So they were lacking that, they were decreasing the KPIs for development, and they want to increase that, and for water and wastewater service was the real deal for them, the easier way to bring up these KPIs. The main problem in Belo Horizonte area, Belo Horizonte is the capital of the state, was to support a better water system was lack of stable energy for the units. So they had the units, they are with already control, they have a control center, but they were lacking stable energy. So the energy was quite unstable and were making some problem for them. They were monitoring, but not in a good way, all the units. So basically they want to bring to monitor and control the new power station and all the water and wastewater system from one control center. So the challenge, that was the challenge. So what is the solution that we are bringing? It's the installation of a rooted PLC with the possibility of, so in this case of Belo Horizonte and Minas Gerais, we do have just one PLC, so it's just one Nexto, and we are controlling more than 2,000 I/O points, more than 5,000 communication tags to the control center, possibility to communicate in a special protocol for the electrical segment, that is IEC 618050, communicate with hundreds of IEDs, so intelligent electronic devices that they already have in the field, integrated with the SCADA system in the control center, hot swapping. So this was a requirement that they had. We need to have hot swapping on the IO modules, and easy to use diagnostic for all the modules. So for maintenance, they want to have full diagnosis from the IO, mainly from the IO modules. So what we did, one PLC next to 3010, communicating with all the modules, all the communication protocols, all the IEDs, and with hot swapping capabilities. So any of these modules, you can just plug it out and plug it in, and you don't lose any kind of control or information from the field. So here we have the information of how many IEDs. So we are talking about 350, around 350 intelligence equipments in the field. And from Nexto PLC and from the control center, you can manage all device and send information from the SCADA to the device using Nexto controller. And we have to have a switch here to connect all the 350 equipments. So what the results, the appliance solution bring, after some years, bring the states of Minas Gerais and one of the 3 best systems in the country. So they increase a lot their water and wastewater system, and because of that, the KPIs of sustainability and development grows up a lot, and they are one of the 3 states at the moment. I'm just running a little bit here, guys, to try to cover all the 6 cases that we have, okay? But feel free to do any questions. Coming to this one, I'll take a little bit more time to explain everything to you. So going to oil and gas, and here again, we are in the big PLC. So what was the challenge? A Dutch company that is a manufacturing of a gas dehydration system was operating on pre-salt FPSOs. So before going further, actually, the requirement, what was the requirements to operate on a FPSO? What is a FPSO? It's a floating production, storage, and offloading ship. Basically, it's a ship. They want to have redundancy on CPUs and network, hot swapping, just like the other case that we saw, and online chains. Before going further, I want just to recap what is a FPSO and what is pre-salt. So pre-salt is something that I don't know if there is any other country getting petroleum from pre-salt. Brazil, the main petroleum that we are extracting is from pre-salt. So basically, pre-salt, it's down there in the sea. So we were used, and most of the countries get salt from the sea from around 2,000 to 3,000 meters of deep in the sea. So we have water here, and we have the first what we call post-salt, and over here we have the petroleum. Then we have a huge, large salt layer, and then we come to pre-salt layer. And over there, we have much more petroleum than what we have here. What is the problem for that? You have around 2,000 meters of deep on water, and then you have more around 5,000 meters of rock, salt, and sand that you have to dig to go over there. So we are talking about from 6,000 to 7,000 deep to extract all the petroleum from there. Okay, so this is the pre-salt. This is the requirements of field that we are looking when we are talking about pre-salt. FPSO, it's basically one big ship that it's just like offshore platform. And the difference here, beside for the pre-salt, that it's down there, and the post-salt petroleum, is that guys over there, they produce much more than a post-salt. So normally post-salt FPSO, they are not like a ship like this. They are something like these guys here. This is how looks like a post-salt offshore platform, and the pre-salt like much more like a ship. They are around 200 kilometers, that it's around 120 miles from the coast, and operating about 7,000 meters, that it's, I would say, 4,000 miles of deep. And they have one well, normally 1 to 2 wells, and they produce the same of a post-salt offshore platform that has around 10 to 20 wells. So it's much more efficient to have these guys here, but much more complex to operate a FPSO for pre-salt than a regular offshore platform. So basically, what was the requirements? Was to automate the gas dehydration. That was a machine to go to the offshore platform. The platform itself is already automated with Autos, so we are using a similar architecture than this one for the platform itself, but here we are bringing just the gas dehydration. Okay, So what was the architecture developed? So what we are using two half cluster redundancy PLCs. So basically, what is that? We are bringing from CPU, that is the CPU over here, that is next to 3030. They are operating in a redundant mode, communication with more than 550 I/O points, including analogs and digital in the field. I will explain in a minute how all this architecture works. The redundancy network is Profibus and is bringing asset management. We are bringing all the information to asset management through the Profibus protocol, going to the clusters, going to the asset management software. So just to give you some idea of what we are using in each rack. So each of this, so this is half rack, this is half cluster. So we have a power supply over here. We have a CPU, redundant CPU next to 3030. We have two Profibus DP master, and we have two redundant Ethernet to the field, so to communicate with the other half and with other devices. And we have two Ethernets going up to the SCADA system and to the asset management software that is going on the control room. A funny thing that happens here, and I would like to take some minutes to explain that, is normally when we are working with redundant network or going down to the field or going to other PLCs, we do have one active network and another that is inactive network. So basically we are running over one network and the other one is just standing by and waiting to act if we have some problem in the first one. So let's call this as network A and this as network B. Okay, going to the field, we are going to next to I/O in the field, and we are going to some other devices or old remote I/O from Autos, in this case that it's Ponto series, and we have support for HART protocol, and in the devices we can use optical link. So we can be very creative over here to use many different ways to connect and to bring all the information. But getting back to the network, so we have network A and we have network B. Normally we see one active and one inactive, so one standing by, just ready to act in any problem. In our case, we have both network acting. So we have network A active, and we have network B also active. What is the difference between the other scenario? If we have both network acting, we can allow two or more major fails, and we keep control of all the process. So in the first scenario that we have one inactive, let's suppose that we have here a wire problem, and then you lose communication with this Profibus head. All the system will shift the communication to network B, so then we'll be able to communicate with this other module and keep control of this remote. We will have this over here coming here and control of this remote, and the same down there with the old device. But let's say that we have a simple fail. Let's say that we have now a major fail, and one of these modules from this rack fail. So the module B of the second rack fail. What will happen? The system have to make a choice. Okay, I will keep rack 1 working, or I shut down that, or I have to do with this one. So the system will fail in some of the racks. There is no other way. You will lose control of one of these two racks, or the first one because of this cable, or the second one because of this module. When you have both network active and both network going with all the information down, if we have here the wire problem, this remote here, the first one, will get all the information from network B. Once that we keep network A running, if we have this module here, a fail on this module here, this remote will get the information from network A. So you keep control of all of the process. And even though we have more modules fail, so let's say that we have here in this module, in the first half cluster, we have a second major fail, that it's this module to fail. If this module fail, the system will switch all the control to the second half cluster that it's just standing by, and we keep control of all those two networks, all the remotes, with all the information in the CPU, synchronize it with the first one. So the field itself from here down, no one knows that what's going on over there, and that we have a major fail here in this module. And the other remotes don't know that we have a fail here in this wire or a fail in this module. Of course, CPU has all this information and will raise a flag, say, hey, we have a fail in the cable, we have a fail in module B of second remote, and we have a fail on module on Profibus master on network A in the first half cluster. So all the diagnoses you have up here and in the control center, but the system itself don't lose control and don't feel these simple or major fails that we may have. So this is the way that we face redundancy. This was delivered to this Dutch customer. And what the results? So featuring hot swapping, redundancy of CPU, and capability to online modification. I didn't said about the online modification. So basically, once that we have the fails, of course, you can just plug it out the module and switch to the new module. This will solve your problem with the fail of the module. The system won't feel that, but the customer also wants the online modification of the application. So the guys can just go there, connect to the Ethernet, and start making some change. Of course, there is security on that. So you have to have a login, you have to have a password, you have to have the right access to do that. But you can start doing some small modifications to upgrade the system or to bring more functionalities to the system. So the solution implemented the delivery security and high availability to the FPSO. And remember, we are talking here about the gas dehydration system itself, but a similar architecture than this one is controlling the whole platform. So we do have advanced diagnosis routine to enable acquisition of precision information from the system. This is what I said regarding the cables and regarding the modules. Just I just bring the additional notes here that it's what I said. So Altus is the main control supplier to Petrobras pre-salt FPSO. And note too, Petrobras FPSOs are breaking production records every year with less oil wells than a regular platform. So from the other one is, if I'm not wrong, 10 to 20 wells, and we are talking here on the pre-salt ones from 1 to 2 per offshore platform. Going further here, so machine manufacturer, and now we are getting back to Nexto Express. So a traditional machine manufacturer with more than 40 years in Brazilian market was looking for a control solution for its new line of thermoforming machines. Just to, I was not used what is a thermoforming machine. This is not a press, okay? This is different from that plastic press that we normally saw. So this is basically, I'll show you a picture in the next slide how does this machine works. And finding out the products, the technology necessary to ensure total harmony between software and hardware of each machine. So basically, of course, as many machine manufacturers, they were looking for size. So size was a problem for them. Cost is always a problem for a machine manufacturing. Features, cycle time, and online programming. So that was these two last ones. So cycle time was really important for them for the precision of the machine itself and for, of course, the speed. and online programming was one of the requirements. So they were looking for a control, a small, compact PLC with online programming to be able to upgrade the machines or to make any changes or maintenance, whatever they want. And they were lacking this kind of product, okay? So this is a conforming thermoforming machine. So basically what we have here is sausage, and the thermoforming build the case or the box for the sausage on top of the sausage. So it's a little bit different from a press machine that you just make the box and then you put the sausage inside. This one can work a little bit different in this kind of architecture. So what was the solution? So at that time we use a 325. So they choose 325 Nexto Express to be the central unit for all the machine and the movements of the machine. So all the drives that it's running on the machine. I know that in some of them old machines that they have, they were using two controls, one for the movements and one for the process itself. But in this new line, they're using just one control, that it's Nexto Express, and they are able to use just one control because of the cycle time. So features several communication interface and supporting a wide range of protocols, such as Modbus TCP. So we are going up with Modbus TCP, OPCDA and OPC-UA, and MQTT. They are not exactly using it. It's a possibility for the future. The controller has the capability to interact with most smart device, and this is something that they are willing to do in the next feature. So bring this machine to the industry 4.0. So basically, what is the architecture that we're using here? So we have the PLC, we have an OptiDrive, that is the inverter over here. The inverter is responsible for controlling all the speed of the conveyor, and of course to handle all the device. Here, as I said before, I like to use CAN-open. So here we are using CAN-open to communicate with the drive. We could be using analog inputs and outputs, but we prefer to use CAN-open. All the Nexto Express from the start one, that is the 300, the 340, all of them has CAN-open, so you can use and save some analog inputs for your application itself. And the PLC, so 325, is interacting with Modbus TCP with X2 base Bayer panel, that is where the operator get all the application supervision and is doing all the process over here. So what was the results? And here we have a huge difference between what they were doing and what they are doing right now. And Express bring new customers for our customer. So the developed application, and this was done together between us and the customer, resulted in important machine productivity gain, which started to produce an average of 4,500 units per hour. That it's around 30% more than the predecessor line. So remember that they were using two PLCs to control the machine at that time, and they have 30% less performance than what they have now. The high performance drew the attention of one of the main food companies in Brazil, which started using the machines of our customer because of this productiveness. So basically, we bring a new product for them. They were saving some money buying just one PLC instead of buying two PLCs, making all the application much easier and much more simple than what they were doing in the past. And they bring more customers because of the productivity of this machine. Food and beverage. Alan, when you want to stop, just let me know. I know that I'm almost in the half hour that I have.
Okay, thank you. Why don't we finish with food and beverage then?
Okay, yeah, works.
Great, thank you. We're okay for time.
So,
okay.
what was the challenge? To control the atmosphere in a restrictive place in order to slow down fruit maturation, such as apple. So this type of structure demands a rigid automation system capable of keeping atmosphere and temperature in the correct level. So basically what they were doing, they were trying to control how is the maturation of the fruit. So let's say that you have an apple, and in Brazil we have some places that produce more apple than the others. And if you want to drive 2 or 3 days in a truck to bring the apple to the north of the country, you cannot bring already maturation apples to there. So this was the requirement. So they want to control to get better price, and to control to don't lose the fruits when they were shipping the fruit to other states. So what is the solution? So that is a large automation system based on Nexto modular. So this is the big guy with distributed IOs. So we have 5 different racks on the field, keeping same performance on all racks. So basically, the big challenge here is to keep all the performance in all the racks the same. So we could not have any change from one to the other. So Nexto modular was the correct choice, okay, regarding the ruggedness and the high availability for the system. And one of the features that make the customer to decide for us was the multitask possibilities on the CPUs. So basically what we have here, so overall in all the system we have around 500 digital inputs, we have around 450 digital outputs, 96 analog inputs, and 8 analog outputs. We are communicating here through Modbus TCP network. As we saw, we have a lot of Modbus here because they are one of the main protocols in Brazil, but you could be using Ethernet IP, you could be using CAN-open, you could be using OPCDA, OPCUA, so you feel free to use any protocol that you want. I don't know why Brazilians like Modbus. I'm not a big fan, but they're using a lot. So in addition to IX series HMI and SCADA system over there. So what are the results? So the applied solution delivers total control of the environment, making possible to set level of elements present on it. So you're controlling all the atmosphere inside of where the apples are. The applied solution also control the humidity and control atmosphere control system, which manage the generation, mixing, and proportion of gases injected in the unit cooling tunnels, making possible to define the maturation progress of the fruit for better quality and decrease of loss. So I don't have the numbers, they didn't open the numbers to us, but we know that they have a huge increase of productiveness, so they decrease a lot the losses because of this better control of the atmosphere inside of the tunnels. Alan, up to you.
Okay, great. Thank you for that. That was various applications that we talked through. Leandro and also Gabe are also available if you have a specific application that you need any support or you'd like to talk to us about, then they're experts in this field. I don't see any questions in the chat, so if there's no more questions, then I'll just wrap things up. This event is recorded. It will be posted online in probably 1 to 2 days' time, so you can reference back to it if you need to, or share it with colleagues. So thank you very much for your time today, and I wish you a terrific week. Thank you. Goodbye.